now we want to talk about gravity. And the idea is that any two objects that have mass are going to be pulled together by the force of gravity. So normally we think about the force of gravity caused by the Earth. And so the Earth would be one mass, this would be the other mass, and then if I let go of it, then the force of gravity is pulling those two things together. But just remember that anything that has mass is going to cause gravity. So that would mean that my head, for example, has mass and it causes gravity. And so if I was in outer space and I was to let this pen go, then you would find that over time this pen would get closer and closer to my head because of the force of gravity. You don't notice it here on Earth because the force of gravity of the Earth is so much stronger than the force of gravity of my head. Okay? Now, notice that the formula depends on two things. So one, it depends on mass. So the force of gravity is proportional, don't worry about that G thing, is proportional to the masses. So you got mass 1 and you got mass 2. So that means the more mass you got, the greater the force of gravity is going to be. But it also depends on the distance between them. And so it's going to be divided by r squared. So that means that the closer two objects get, the smaller the r gets, and the bigger the f gets. So if you got two objects and they're really, really, really far away, they don't feel much gravity. But the closer those objects get to each other, the force of gravity is going to increase. That's very important because we're going to use that principle in order to map the inside of the Earth. How do we measure gravity? Okay, so the device is going to be called a gravitometer. And all it is it's a mass attached to a spring, and then when you go over something massive, then the mass of this object down here is going to exert a gravitational force on this mass here, and it's going to stretch the spring. And then you can attach a pen to the spring, and then it will tell you how strong that force is. So a gravitometer measures gravity. So how could we use that to locate things inside the Earth? Well, for example, if you've got this gravitometer and it goes over a cave, for example. So a cave would be an absence of mass. So then that would mean that the little weight would be raised up. So you could locate a cave system underneath the ground. On the other hand, let's say that you are looking for lead. So lead is very massive. It's dense, and so for the same amount of volume, it's going to have more mass. So if you're taking your gravitometer and you move over a lead deposit, then all of a sudden that little mass is going to be pulled down, and you would be able to locate the lead. Okay, look at what happens on the floor of the ocean. So let's say that you have the floor of the ocean and then there's a mountain like this. Well, this mountain has a lot of mass. So that means that that mass is going to be pulling on the ocean water. And so it's going to make that water collect around the mountain. And so it's going to raise the level of the water above that mountain system. And so we could use that again in order to locate where that mountain system is. You can also measure tectonic movements. So the mantle is composed of more dense rocks than what the crust is. So you have the core, the mantle, and then the crust. The mantle is going to be composed of very dense rocks compared to the crust. So that means that for the same volume, the mantle rocks are going to have more mass than what the crustal rocks are going to have. Okay, so if uplift is occurring, so where you have uplift, so stuff is doing this, then that means the mantle is going to be closer to the surface. That means the distance is going to be smaller. If the distance is smaller to the surface, that means the force of gravity is going to be greater, and then that's going to be called a positive gravity anomaly. Okay, where you have subsidence going on, so that's where material is going down like this, then that means the mantle material is further from the surface. R is going to be bigger, and so that means F is going to be smaller. So that's going to be a negative gravity anomaly. So we can tell by taking our gravitometer and moving it across the surface by looking for positive and negative gravity anomalies, we can tell whether the ground is going up or whether the ground is going down. So we could use that to map the inside of the Earth. And so positive gravity anomalies are associated with rifting, because where the ground is being pulled apart, what's happening in the asthenosphere? Material is coming up, and we said that that would cause a positive gravity anomaly. On the other hand, negative anomalies would be subduction, because material is going down at a subduction zone. And so this picture here shows you positive and negative gravity anomalies in the United States. Okay, let's take a break, and when we come back, we're going to talk about magnetism and electricity.